Okay, so we're on to paper 2, which is just for the specialist only. So, question 1, I'm going to look at the tennis ball when it's released. Draw a labelled arrow to show the force acting on the tennis ball at the instant that it's released, right? So if it's, they're giving you a bit of a clue there because they're saying the force, okay? So there's only one of them, and it's at the instant when it's released. So when it's first released, its velocity is 0, so there isn't any air resistance yet. Okay, so there we go. Is that going to get me a mark? No. What have I missed out? I haven't labelled it. Okay, so weight is the correct label there. It's okay to draw the label, draw the arrow as long as it's attached to the object. Some of you drew it from the centre of mass, which is even more correct. Okay, but either of those two arrows is absolutely fine. So for the next part of the question, it's asking about a change in momentum, right? So I need to look up the momentum formula. Okay, and it's there it is. There's some additional equations required for the triple award paper 2. So you can see here's momentum, P equals mv, so we're going to use that. And so we've got the, if we're trying to calculate the change in momentum, then that means that we need to know the final momentum, okay, minus the initial momentum. All right. So you can see from the, you know, if we just think about what was happening, it was travelling downwards at a velocity of 2.5 meters per second. Okay, and then it's travelling upwards at a velocity, final velocity of 1.9 meters per second. Right. So what we've got to do is we've got to choose which direction is our positive direction. Okay, I'm going to choose this as being my positive direction, which means that this number here is positive, okay, and it means that this number here is a negative number. All right, and that's going to be important when we get to the substitution stage. Okay, so the change in momentum is equal to mu minus mv, and then we can substitute. Okay, so 0.057 times by what was it again? 2.5. There we go. Minus, and then I'm going to put some brackets around here. 0.057 times by minus 1.9. Okay, remember it was travelling upwards, so because it's in the opposite direction, it's going to have the opposite sign to it. And that means when you take your calculator and you work this out, this bit over here becomes 0.14 kilogram meters per second, and this one becomes minus 0.11 kilogram meters per second. Okay, it's taken me a long time to get there, but you can see where I was going with this. It's 0.25, and then the units are kilogram meters per second. If you can't remember what the units are, it's pretty easy to work out. Okay, you've got m times v, which means kilograms from the mass, and meters per second for the velocity. Alright, so that gets us 4 marks. The ball is in contact with the ground for a time of 6 milliseconds. Calculate the force exerted on the ball by the ground. Okay, again, I'm going to have a look at, can't remember the formula, so I'm going to look it up in my booklet. There we go. The force is the change in the momentum over the time taken. Okay, so the resultant force is equal to change in momentum, okay, over the time taken. Just work that out in the previous question, okay, and of course the sneaky bit here is that that's actually 6 times by 10 to the minus 3, or 0.006. Work that out on a calculator, and you're going to get 42 newtons. Okay, and then we're going to think about the direction, right? Now, this resultant force is going to cause an acceleration, right? So, which way is the ball accelerating? Well, it was falling downwards with a velocity of 2.5 meters per second, and then it's going upwards with a velocity of minus 1.9 meters per second. So to make that change in the velocity happen, there must have been an acceleration. Okay, first of all, the ball decelerated to zero velocity, then it accelerated upwards. So because the acceleration's upwards, that tells you that the resultant force pushing on the ball must have been upwards, right? So it's a reaction force between the floor and the ball, okay, pushing upwards. All right. Oh, there's more. It's quite a long question, this one. Now we've got to do an investigation to compare the coefficient of restitution for different types of balls. All right. And then it says design a method. So the first thing that we've got to do is we've got to identify the variables in the investigation. Okay. So we look back at here, different types of balls. So that's going to be our independent variable. That's going to be the thing that we change, right? Okay. So if you literally write down independent variable equals different types of balls, that'll get you the mark there. And then the dependent variable, okay, if you look here, is actually going to be we're going to measure the height, okay? So it's going to be the position at the top of the bounce, right? So that's going to be our dependent variable. I mean, you could argue that you're trying to compare coefficient of restitution, so that could be a dependent variable, and they did allow that as well. But the thing that you actually measure is the position at the top of the bounce. So I think that's probably the stronger answer there. Then we've got to think about what things we're going to control. Okay, so we've already got a mark for IV, we've already got a mark for DV. Now we've got to think of control variables. Now, there's lots of things that you could have here, like for example the drop position. Okay, we're going to keep that the same. All right, the surface that we're dropping onto, we're going to keep that the same. You know, temperature of the ball, the fact that we're releasing it from rest. There's loads of things that you could think of, but you're only going to be able to score 1 mark for the CV. Okay, so you can't write down 5 CVs and get 5 marks. Okay, that's not how the mark scheme works, right? So any control variable, right? Actually, sorry, I'm looking at the mark scheme again. From those 3 things, IV, DV and CV, okay, you can score a maximum of 2 marks. So if you just talked about the IV and the DV, you get 2 marks. If you talked about all 3, you get 2 marks, okay? That's because this part they awarded a maximum of 2 marks for, okay? And, okay, so the maximum that you can get for this next bit is similarly 2 marks, okay? And the maximum that you can get for this next bit is similarly 2 marks. So they ask you to do 3 things, okay, and they're trying to make sure that you've done all 3 of those things by giving them equal weighting in the marking scheme. Obviously, still the maximum amount of marks that you can get is 5 marks. Okay, so let's have a look at how to obtain accurate measurements. Okay, if you're trying to measure something accurately, it means that you're measuring what you actually measure. So, for example, talking about the fact that all of these measurements, are made vertically. Yeah, that's a very poor vertical meter ruler right there. Okay, and a way to make sure that things are vertical is you could use, like, for example, a set square, okay, against the ground to ensure that you're dropping things vertically, right? So you could use a set square there. Measuring at eye level, okay, you know, that's the favourite response for when you're using a measuring cylinder, isn't it? That you've got to take all of your measurements at eye level, okay, and that helps avoid parallax error. Okay, so for example, you know, getting down at eye level to take this measurement against the ruler, okay, so that you avoid parallax error. And another thing that quite a few people thought of is that you could use like a slow motion camera. You know, you could take a video clip and then play it back in slow motion, and that would allow you to pinpoint exactly where this kind of top height was. All right. So any two from those to get you the marks for accuracy. Okay, and then how to obtain reliable results. We could talk about repeats, but the best answers talked about repeats, you know, from each height. Okay, so yeah, making sure that you are measuring multiple repeats from the same. Sorry, not from the same height. We're changing the ball, aren't we? Okay, my bad. Okay, so taking multiple repeats for each different type of ball. Okay, and then identifying any anomalies in the data and removing them. And then, after you've identified the anomalies, calculating a mean value or calculating an average value for those. So again, three ways that you could have scored the marks for reliable results. Any two from those would have done. And that, I think, is finally the end of a very long question one.